let's take a look at the exercises for chapter 7. For the multiple choice questions, a simple random sample of 100 observations was taken from a large population. The sample mean and the standard deviation were determined to be 80 and 12 respectively. The standard error of the mean is, I'm looking for sigma x bar. Sigma x bar is equal to sigma divided by square root of n. Sigma is given to be 12, n is 100, square root of 100. Therefore, the standard error of the mean will be 1.2. So the correct answer will be A. As the sample size increases, what will happen, will occur? So let's take a look at the formula. Sigma x bar is equal to sigma over square root of n. As the sample size increases, that means that I am dividing with a higher number. That means that the standard error of the mean will go down. So sigma will be the correct answer. Random samples of size 81 are taken from an infinite population whose mean and standard deviation are 218 respectively. The distribution of the population is unknown. The mean and standard error of the mean are. So we know that based on the main properties, mu x bar is equal to mu equal to 200, and that sigma x bar is equal to sigma over square root of n, which is equal to 18 divided by square root of 81, which will give me 2. So the correct answer will be D. Random samples of size 525 are taken from an infinite population whose population proportion is 0.3. The standard deviation of the sample proportion is, so all I'm looking for is sigma p bar, which is equal to the square root of p times 1 minus p over n. We know that p is 0.3. 0.3 times 1 minus 0.3 divided by n is 525. So this will be equal to 0.02. From the population of 5,000 elements, a sample of 225 elements is selected. It is known that the variance of the population is 900. That means that sigma square is equal to 900. I'm looking for the standard error of the mean. Sigma x bar is equal to sigma over square root of n. I do not have sigma. However, I can find sigma from sigma square from the variance. Sigma is equal to the square root of the variance, square root in this case of 900, which is equal to 30. So 30 over square root of 225, and this will be equal to 2. So the correct answer is B. Let's look at the problems now. A large population of students spends an average of $10.50 a day on dinner. The standard deviation of the expenditure is 350. A simple random sample of 49 students is taken. So we have x bar 1050, we have the sigma is equal to 350, we have n is equal to 49. What are the expected value? This is the mu. What are the expected value and the standard deviation of the sample mean? So we have expected value and also sigma x bar. We know that the expected value of the sample mean is equal to mu x bar, which is equal to mu, which is equal to 1050. Sigma x bar is equal to sigma over square root of n. We know that sigma is 350 over square root of n is equal to 49. So this will be equal to 0.5. So the standard error of the mean is 0.5. What is the probability that the sample mean will be greater than 11.25? So I'm looking for the probability that x bar is greater than 11.25. We draw the normal distribution. Mu x bar is 1050. 11.25 is to the right of the mean. Greater than 11.25, I'm looking for a tail. Now, the z-score will be equal to 11.25 minus 1050 over 3.5 divided by square root of 49. When you do your calculations, you want to make sure that you use parentheses, or you could have simply substitute this with 0.5 straight away. So the z-score in this case will be 1.5. If we look it up on our z table, 1.5 will give us a probability of 0.4332, and since I'm looking for a tail, 0.5 minus 0.4332 will give me a probability of 0.0668, and this will be your answer. What is the probability that the sample mean will be between 10 and 1080? So I'm looking for the probability of x bar to be between 10 and 1080. We draw the normal distribution, normal curve. Mu x bar is the same, 1050. 10 is to the left, 1080 is to the right of the mean. And since I'm looking for x bar to be between these two values, I'm looking for this area. We have two values. We're gonna calculate two z-scores. So for the first z-score, for 10, we will do 10 minus 10.5 over 3.5 divided by square root of 49, or 0.5, which will be equal to -1. Z2 is 10.8 minus 10.5 over 3.5 divided by square root of 49, and this will be positive 0.6. We take the absolute value for Z1, we look it up in our Z table. This will be 0.3413, and for 0.6, this will be 0.2257. Since the mean is inside the area we are looking for, we will be adding the corresponding probabilities. So 0.3413 plus 0.2257, this will be 0.5670. Let's look at the second problem. The life expectancy in the US is 75 with a standard deviation of 8. A random sample of 100 individuals is selected. So mu is equal to 75, sigma is equal to 8, n is equal to 100. What is the probability that the sample mean will be greater than 76? So I'm looking for the probability of x bar to be greater than 76. Mu x bar is the same as mu, which is 75. 76 is to the right of the mean, and greater than 76, I'm looking for a right tail. We calculate the z-score, 76 minus 75 over sigma, which is 8, divided by square root of 100. So this will give me a z-score of 1.25. 1.25 will give me a corresponding probability of 0.3944, and since I'm looking for a tail, I will do 0.5 minus 0.3944, and the probability that I'm looking for will be 0.1056. For the same problem, I want to find the probability that the sample mean will be less than 73 years. So I'm looking for the probability of x bar to be less than 73. We draw the normal curve. Mu x bar, same as mu 75. 73 will be to the left of the mean. Let's say somewhere over here, less than 73. That means I'm looking for a left tail. Z-score 73 minus 75 over 8 divided by square root of 100. The z-score in this case will be negative 2.5. Negative 2.5, we take the absolute value, 2.5 will give me a probability of 0.4938. I'm looking for a tail. Once again, 0.5 minus 0.4938, and this will be a probability of 0.0062. What is the probability that the sample mean will be greater than 72.5 years? So I'm looking for the probability of x bar to be greater than 72.5. We draw the normal curve. Once again, mu x bar is 75. 72.5 is to the left of the mean because it's less than the mean. I'm looking for an area where x bar is greater than 72.5. That means I'm looking for the whole area to the right. The whole area to the right. Z-score 72.5 minus 75 over 8 divided by square root of 100. This is going to be negative 3.13. You always round up to the second decimal because your table only goes up to 2 decimals. So 3.13 will give you a probability of 0.4991. This area I already know is 0.5. The mean is inside this area, so I add the corresponding probabilities. So the probability of x bar to be greater than 72.5 will be 0.9991. A very, very high probability of that occurring. Let's look at problem number 3. The lengths of pregnancies are normally distributed with mu equal to 280, sigma equal to 20, n equal to 100. Find the probability that the mean pregnancy will be between 273 and 286 days. So I'm looking for x bar to be between 273 and 286. Let's draw the normal curve. Mu x bar is the same as mu, 280. 273 is to the left of the mean. 286 is to the right of the mean, and I'm looking for this area, the area between these two values. We have two values. We need to calculate two z-scores. Z1 for 273 will be 273 minus 280 over 20 divided by square root of 100, and this will be negative 3.5. Z2 will be 286 minus 280 over 20 divided by square root of 100. So this will be positive 3. 3.5 will give me a probability of 0.4998, and 3 will give me a probability of 0.4987. So the probability that x bar will be between these two values, the mean is inside the area we're looking for. We're simply adding the corresponding probabilities, will be 0.9985. A very high probability of that occurring. Now, problem number 4. The body temperature of adults are normally distributed with a mean of 28.6, standard deviation, this is your mu, standard deviation sigma of 0.6, n is equal to 25. Find the probability that the mean body temperature is less than 99 degrees Fahrenheit. So let's see what we have here. We draw the normal curve. Mu x bar is 98.6. 99 is to the right. And I'm looking for X bar to be less than 99. So I am looking for this area, the whole area to the left. We already know that this part of the area is 0.5, and now we're looking for this part of the area. To find this part, we need to calculate the z-score. 99 minus 98.6 divided by 0.6 over square root of 25. Use your parentheses, do your calculations, and you will have a z-score of 3.33. If you look it up on your z-table, this corresponds to 0.4996. Once again, the mean is inside the area. We add the corresponding probabilities. So the probability of that to occur, of X bar to be less than 99, is 0.9996, a very high probability. Let's look at the next problem, problem number 5. In a restaurant, the proportion of people who order coffee with their dinner is 0.9. A simple random sample of 144 patrons of the restaurant is taken. What are the expected value and the standard deviation of P bar? The expected value of P bar is 0.9, the same as P, which is 0.9, and the standard deviation sigma P bar is equal to the square root of P times 1 minus P over N. So we have 0.9 times 0.1, 1 minus 0.9 over 144. If we do the calculations, this will be 0.025. Now, what is the probability that the proportion of people who will order coffee with their meal is between 0.85 and 0.875? So I'm looking for the probability where P bar is between 0.85 and 0.875, basically. Now, let's draw the normal curve. We have P 0.9, we have 0.85 to the left, 0.875 also to the left, and I'm looking for this area between these two values. So we will calculate two z-scores, z1 and z2, one for 0.85 and the other one for 0.875. So P bar minus P over square root of P times 1 minus P over N. So we have 0.85 minus 0.9 divided by 0.025. We already have that answer. So this will be equal to -2. And for the second z-score, we will do 0.875 minus 0.9 over 0.025, and this will be -1. So we will find the probability of 2 and the probability of 1, and we will subtract them. The mean is outside the area that we're looking for, so we will subtract the corresponding probabilities. So this part that corresponds to a z-score of 2 is 0.4772, and this area is 0.3413. So to find this probability, we will do 0.4772 minus 0.3413, and the answer will be 0.1359. What is the probability that the proportion of people who will order coffee with their meal is at least 0.945, at least 0.945. So let's look at our normal curve. I'm looking for P bar to be greater or equal to 0.945. Normal curve 0.9. We have 0.945 is to the right of the mean, 0.945, greater than 0.945. I'm looking for a right tail. We calculate the z-score, P bar minus P over square root of P times 1 minus P divided by sample size. So we have 0.945 minus 0.9 over, if we were to do the whole thing, that would be 0.9 times 0.1 minus 0.9 over 144. So the z-score would be equal to 1.8. We go to our table, we check for a z-score of 1.8. This will give us this area over here, which would be 0.4641. I'm looking for a tail, therefore I need to subtract from 0.5. 0.5 minus 0.4641, and the probability that I'm looking for will be 0.0359. Make sure you use your parentheses here. And this completes the exercises for chapter 7.